which is the outermost layer of the Sun. These payloads use electromagnetic, particle, and magnetic field detectors. First among the four remote sensing payloads is Visible Emission Line Chronograph (VELC). Particle and magnetic field detectors. First among the four remote sensing payloads is Visible Emission Line Chronograph (VELC). Solar soft X-ray flux to study solar flares. This payload is developed by UR Rao Satellite Center. Third payload is the Solar Ultraviolet Imaging Telescope Suite, which is a UV telescope to image the solar
जहाँ विरासते हैं कालों के काल महाकाल, जहाँ हर 12 वर्ष में लगता है सिंहस्थ, जहाँ से ली स्वयं भगवान कृष्ण ने शिक्षा, जो है महाकवि कालिदास की नगरी, जहाँ धर्म के प्रति है लोगों की अपार आस्था, जहाँ हर दिन धर्म का होता है गुणगान। मंदिर, मस्जिद, गुरुद्वारे, गिरजाघरों में जुटते हैं लोग, जहाँ से है देश प्रदेश की राजनीति का बड़ा वर्चस्व।
The fifth payload is the one which is meant for in situ observations. This is Aditya Solar Wind Particle Experiment, or otherwise called as ASPECS, which comprises of spectrometers to measure low energy particles and high energy ions. This payload is developed by Physical Research Laboratory. The sixth payload is Plasma Analyzer Package for Aditya, in short PAPA. It is designed to understand the solar winds and its composition and perform mass analysis of solar winds. This payload is developed by Vikram Sarabhai Space Center. The seventh payload is a magnetometer or MAG developed by LEOS, which will measure the low intensity interplanetary magnetic field in space using a pair of This payload is developed by Vikram Sarabhai Space Center. Seventh payload is a magnetometer or MAG developed by
आदित्य L-1 उपग्रह में नितभार के बारे में जानते हुए इसमें सुदूर संवेदन नितभार हैं और यथास्थिति प्रेक्षण नितभार लगे हुए हैं। सुदूर संवेदन नितभार में सूर्य का प्रेक्षण करने के लिए VLC स्थिति नितभार में आदित्य सोलर विंड पार्टिकल एक्सपेरिमेंट। इसका उद्देश्य है सोलर पवन, सौर पवन में भारी आयंस, प्रोटॉन्स और और अंत में मैग्नेटोमीटर लेबोरेटरी फॉर इलेक्ट्रो ऑप्टिक्स सिस्टम्स बेंगलुरु द्वारा निर्मित किया गया है। यह कोस्ट फेज जारी रहने वाला है। आइए इस अंतराल में आपको लिए चलते हैं इस मिशन से जुड़ी चर्चा में, जहां वरिष्ठ वैज्ञानिक हमारे प्रश्नों के उत्तर देंगे और फिर इस चर्चा के बाद हम वापस आएंगे लाइव इवेंट्स में।
As we are in the no visibility region of the flight path, we take you to the discussion.
And what are the objectives of this mission?
Thanks a lot. First of all, let me thank ISRO as well as the Government of India for providing a great opportunity for the solar and heliophysics community of the country. Both solar, heliophysics as well as astronomy thrives on data. More the data you have, we get more understanding about the system. And sun is our own star, our dearmost star. So understanding them is much more important for our everyday life. So this mission, Aditya, when it was conceived initially, with a support Professor U.R. Rao, along with Dr. Srikumar and Professor Srinivasan, we made sure that we will have a unique data set which is not available from any other missions in international mission. So the 7 payloads, what was conceived for this particular mission, will provide a unique set of data which is currently not available from any other mission, which will provide us new insight into the solar and heliophysics community in India, and provide some important aspects like the initiation of the coronal mass ejections, the speed at which it gets initiated, and some wavebands which are very important for the Earth ionospheric connections, like near ultraviolet band, and the high energy particles, which is high energy radiations as well as particles which is coming from the solar flares and coronal mass ejections. So these are the informations which would be available from this particular mission, which will allow us to understand the sun.
When the sun becomes angry, there are two types of process which happens. One is solar flares, that means electromagnetic radiation, which reaches the earth in 8 minutes. But along with that, there is a mass which is also ejected out in form of plasma. And that can take about 2 to 4 days to reach the earth. What we are looking for from the Aditya L-1 mission is to see the impact of solar flares as well as coronal mass ejections as they come to the earth. We have instruments which look at not only in the sun direction but also in other directions, for example perpendicular to ecliptic or in the earth direction. The impact is that we need to see when the sun becomes quite angry, what are the ways in which it is affecting the planet Earth. And at one point being at point one, which is just 1% away from Earth, it is able to provide us a lot of new information of the plasma and the electromagnetic radiation.
See the corona. Why corona? Because when sun burps, when sun is angry, the corona is what it takes the matter away. Now, what is unique about this instrument? This is going to see the corona as close as possible from the disk of the sun. Now, what is so challenging about it? It is because the sun's corona is a million times fainter than the disk of the sun. So you have to not see the disk of the sun, but see only the corona. So this instrument is very difficult to make, challenging, but it is made. Now it's going to the orbit. So what we plan to study using this instrument is the corona, its dynamics. Through this emission line, you can actually measure the velocity by simple physics called Doppler effect. So you can measure the velocity, you can measure how much matter is moving, and eventually how that matter will come to the Earth and the heliosphere. So it's overall this instrument, along with the others, of course, the other PI will also be explaining about it. So these whole stickers will give you a lot of information regarding not only the sun but also the heliosphere. Thank you.
That was very interesting, doctor. Thank you very much. And now we'll move on to Dr. Durgesh Tripati. You are the PI of the for the payload suit. How is that different from other telescopes like Hubble or James Webb? And what are you going to investigate using this?
Good afternoon. My voice is going to mumble by because I'm still in the awe of the launch and one of the